Hello, my name is Todd Rothman. Welcome back to Organic Chemistry 1. In this video, we're going to go over cycloalkenes, alkanes, and alkynes, as well as bicycloalkanes. Okay, so that's the goal for this video set. Let's get started. The first one is talking specifically about cycloalkanes, alkenes, and alkynes. Okay, so how do we name them? Well, here's the general template that we're going to follow. What we do is, we're going to start by naming all substituents just the same as we did with alkanes. So with alkanes, you always put the substituents first, you identify their position by a number, and then you go on with the parent. But in this case, the parent is made up of two different components, and that is the prefix and the infix. Those two combined make up the parent name. And then finally, there's a suffix, which right now is very simple until we learn about functional groups. For now, a suffix is simply an E, adding an E at the end. But we'll learn about other suffix names that we can use once we get into functional groups. But these are the components that make up the name. So now, the substituents is pretty clear. If you watch the previous video on alkane nomenclature, it's all the same stuff that we discussed there. So you've got all the branches that are sticking off the parent. That's what we're looking for. And of course, branches are alkyl groups or halides. Those are considered substituents. All substituents must have a number to identify its position. Even if it's on the same carbon, you have to write that number twice. Okay, so you always have to have a number for each substituent. And then we could use di, tri, tetra, penta, and so on in order to identify the same substituent more than once. Okay, so again, if any of this doesn't make sense, go back to the previous video. I go over all the rules. Okay, so that's all pretty much old news at this point. Now, the prefix is new. Now, what this is this is the first part of the parent name. And what we do is we always start by writing cyclo, because we're dealing with rings. All rings are cyclo. So it's a cyclo and then whatever parent. So let's say it was a six-membered ring. It would be a cyclohexane. Now, notice that before we get to the ane, or ein, that's called the infix, we stop short at the alk component. So, for example, cyclohex, and not ane yet. You don't write ane yet. So cyclohex would be a six-membered ring. Cycloprop, cyclobute, cyclopent. You can't really have a cyclometh or eth. Let me just erase that. So it's prop and onward. Okay, so that's the prefix, cyclo, and then whatever number of carbons make up the ring. Now the infix is whether it's an alkene, alkyne, or alkane. So if it's an alkane, it would be cyclohexane, an. See that? If it was a double bond in the ring, cyclohexene, en, and so on. So that's the infix part. Now, what I wrote here is that the alkene and the alkyne have to have a number to identify where it is. Let me just show you what I mean by this. So let's do an example. Let's do 3 examples. Let's say we have well, actually, let's just do 2 because we're just starting out. So here's a double bond right here. Now, this right here, these are 6-membered rings. If I number around the ring, it's 1, 2, 3, 4, 5, 6. And we'll learn soon that number 1 should be the double bond. When you have a choice in a ring, a straight chain, number 1 must be the end, right? One end to the other end. But in a ring, anywhere is number 1. So if it's up to you, you always pick the double bond carbon as 1. Now, when you do this, you want to do a continuous 1 to 2 for the double bond. You should not do 1 and then this is 2, 3, 4, 5, 6. Because if I say that the double bond begins on 1, then you automatically know it also is continued on number 2. You can't work around it. It must include in order 1, 2. Okay? So this would not be correct. The way that we would number this is over here is number 2. Has to be that way. 3, 4, 5, 6. No matter how much branching is going on, which we'll learn about soon, if 1 is double bond, then 2 is double bond. If 3 is double bond, then 4 is double bond. Always in order. Okay, so this first one, we'd say it's a cyclo. There's 6 carbons, so hex. And then the fact that there's no double bond or triple bond in here, it's an ane. And then the suffix is always the same, just add an E. We'll learn more suffix rules in the next video, but for now, add an E. So here, it's a cyclo, hex, and now there's a double bond, so it's an ene, E-N, and then add the suffix E. Now here's the thing. You have to, like I wrote in this note up here, you have to specify where the double bond is located. You have to say it. And what you do is you say where it begins. So if it's carbon 1 and 2, it begins at carbon 1. So you'd write 1 cyclohexene, or you could write cyclo hex, and then before you begin the infix, you would add the position 1. So 1 ene. See that? These are all acceptable ways of writing it. Either you write the number 1 before the cycle, before the prefix, or you write it right before the infix. Those are both acceptable. But the truth is, if all you have is a double bond and nothing else, you could just write cyclohexene, because there is no, it's not ambiguous as to where it is. It must be number 1. So whenever there's no way it could be anything but number 1, you could leave out the reference of the position. That's the only time. Okay? So these three are all acceptable ways of naming cyclohexene. 1 cyclohexene or cyclohex 1 ene. They all mean the same. Okay? So again, the infix, you could number before that, or you could number before the prefix. We'll see examples soon. All right. Now, as I mentioned here, the only other thing here is that the other note is that we're going to see more examples of suffix changes, but not until the next video. So for now, just add an E for your suffix. All right, let's put this together, and I'm going to show you some rules as we go through examples. Now, here are the general rules, and you could read up on this, but it's really a practice thing, right? You have to work with me to see these rules in practice, and that's what we're about to do. Okay, so I'll kind of scan through the rules real quickly with you, but again, you should just go back and read these rules. So this rule, I think, is very clear. We've been through this a few times now. When you organize the name, it's alphabetical priority, not numerical priority. Okay, you know about the di, tri, that you could ignore those except for iso. Again, this is all review from the previous video. Now here's something. If there's only one substituent off the ring, only one, see that? Then you don't need to say the location. It is implied. It's assumed to be number 1. So if you have a ring with one branch, you don't have to say 1 whatever. Just say the name of the branch. That's it, because you know it's position 1. Same thing with the alkene. If there's only a double bond, you don't have to write 1 double bond because you know it's going to be 1. That's the point. Only if there's more than one branch or more than one complexity, then you have to start citing exactly where things are. Okay? So that's the point there. Now, if there's more than one substituent, begin by numbering at the one substituent and continue clockwise or counter to the other. We're going to see this in practice. It's a lot easier to show you than it would be in any other way. So, but I'll give you a quick example. Well, you know what? Not even going to bother because we're going to see it right now. So you can come back to this again after we do some practice together. If only 2 substituents, okay, whenever you have 2, then they're always the same distance away, numbering-wise. So you do it alphabetically. So whoever wins alphabetically is the first number. That's what this rule says. Never name the compound. Oh, this is super important. When you have a ring, and then you have something off the ring, you don't want to include the parent as being both. Sometimes people would come up to me in my sessions and say, I don't understand. Why did you say it's a cyclohexane? Shouldn't it be 6, 7, 8, 9, 10, 11 carbons, right? Because if you include this plus the straight chain, you can't do that. You're either going to name it a ring, and that in which case you have to only count the carbons in that ring, or a straight chain, but you can't do both. So it's either a ring or a straight chain, but you can't combine the two into one parent. So if this is so in other words, you can't say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is incorrect. Okay, this is wrong. Okay, that's not the way it works. Either a ring or a straight chain, but not both combined. Okay. Finally,